And welcome back. We were left with the last topic, which is passing data to functions and getting data back from the functions. Um, Considering the different options that we have the first option, the first possibility is the different ways that we can pass data, pass by reference, value, or pointer. The second way is whether we are sending a data or we are returning a data. And the last way is the type that we are passing, whether it's integer, array, class, pointer, reference, function. So we have uh, in total 72 possibilities. 3 options for the way that we are passing data, 2 options for the uh, 2 options for whether we are sending a data or receiving data, and 12 options, at least 12 options for the uh, data type. So we won't cover all of these topics. We won't cover all of these options. We only focus on the important ones. And yeah, so in this notebook right now, I will go to the code, and we will discuss all of them, all of these important cases one by one. All right, so let's start by discussing passing by value and reference, and passing by pointer. Um, these are the prototypes of the function. I have the implementation also here in order to reduce the number of lines. But the thing is, in your code, you have to have the prototypes, only the prototypes before the function, and the implementations should go after the main function. But here, for reducing the number of lines of the code, I have put the implementation here as well. This is what I'm doing inside this function. It's very simple. I'm changing the value that I'm receiving to another number. So in the main function, I have number 1, 2, and number 3 initialized with 1, 2, 3. And before I call these functions, before I call function 1, function 2, and function 3, I'm printing their values. It should be 1, 2, 3. And after that, I call these functions. Inside this function, I'm changing the values to 10, 20, and 30. But you can see that only the second and the third functions, they change the value, and then the changes are reflected, and and inside the main we got the updated value for num2 and num3, and num1 is still 1 regardless of the change that we had here. Why? Because we passed the value uh, by a copy. We pass the value we pass this variable by value. We pass the copy of that. All right, these are the 3 first cases. I will comment them out and go to the second part. Imagine for the next, our purpose is creating a variable inside a function and returning that to the main function so that you can later use that inside your main function. First, I'm returning a number. This number will be returned by value, which means that when I'm running this function, for this int number will be created, and then I will return its value to the calling function. In our case is main. But the thing is, when I'm done with executing function 4, this number variable will get destroyed, and the value of that will be returned. And inside my uh, inside my main function, I can later store that value, which is 40, and I store that in num4. All right, so this variable will get destroyed automatically by compiler. Why? Because we are going out of the scope of this number. When we are done with the execution of function 4, this number will get automatically destroyed by but the value of that will be returned. The value is different from the actual variable that we have. Imagine at this point, when you are at the last line, you are you have deleted this number, but you just return the value of that, which is 40. All right. Okay, what about the other cases? Other cases are interesting. We have a local variable and we are returning a reference, and in the second one, in the second case, the function 6, we are returning the address. We are returning address by ampersand, address of this local variable, but it's invalid, and compiler should prevent us from doing so, because we are returning an address or a reference to a local variable. But we know that when you are done with your function, when the execution is finished, the local variable will get automatically destroyed. So you cannot return a pointer or a reference to a local variable, and that's why when I run this program, I will get error warning, reference to a local variable n returned, address of a local variable n returned. So this is the reason that I am getting these errors. So how can I create a variable inside a function and return that into the main? The answer is you can dynamically allocate a memory block, and we discussed that previously, that dynamically allocated memories don't get automatically destroyed and don't get automatically deallocated, and it is up to you to keep track of the address of those blocks and free them up whenever it's necessary. So when you are done with this function f, the compiler won't deallocate or destroy this memory block, this new int 70, to which you have this pointer. And when you are returning the address of this block of memory on heap, it's completely valid, and you can later use this address in your main function to change this data, to print that, or do whatever you want. Okay, here I'm creating a pointer 7. I've called that pointer 7, and I'm storing the result of function 7 y, because function 7 returns a pointer, not a value. So that's why I have a pointer here to store the result of function 7. And here with a star pointer 7, I am dereferencing pointer 7 to print the value. And remember that when you are done with your the memory block that you allocated, you have to deallocate that with delete. Let me run this code. All right. By calling function 7, we dynamically allocated the block of memory on heap, and the value is 70. All right, let me comment this out and go to the next part. Another important note is arrays always get passed by reference. You cannot pass arrays by pointer or by reference. They get automatically passed by reference. So here in function 8, I'm iterating through an array and printing the values. And when I'm calling this array, when I'm calling this function 8, I'm only passing the name of my array without any ampersand, without any star, and then 2 is the size of my array. And when I run my code, you will see that I have one print statement inside function 8, and then I'm iterating through all the elements and printing them. That's what you can see here. All right, this is the next point. Let's go to the interesting part that we have. I have two functions here, informal greeting and formal greeting. In informal greeting, I say, hey, name, welcome back. And in this function, in the second function, formal greeting, I say hello, name, and then new line. Okay, you remember we had function as a data type. This is what I'm going to discuss right now. We can have a data type, we can have a data type, function data type, and here in this line, void means is referring to the type that gets returned by informal greeting function, and greet1 is the name of that variable. It's another name for, you can think of that as another name for this function. And the type of this greet1 is a function, and the address is the address of informal greeting. And the second variable that I have is greet2, but greet2 has a type of function, and its address is formal greeting. So when I call, but before calling greet1 or greet2, let's just simply use informal, or anyway, it doesn't matter, formal greeting, and pass one name and see what will happen. Hey Reza, welcome back. This is exactly what we expect from this function. Informal greeting prints this line and then some other new lines. All right, let's comment this out and uncomment other lines. Okay, right now I'm calling greet1. Greet1 is a variable, but it's from a type of function, and it is referring to informal greeting because I passed the address of informal greeting. And if I pass Reza, you should see, or any other name, you should see the change here. Hey, and any other name, welcome back. I can also change this greet1 to greet2 to have a formal greeting, hello. Any other name. All right, this is how we can have a function as a data type. Next, we will see how can we pass a function to another function. Imagine we have a function and we call that at the beginning of the program. It is called start the program, and it receives a function for greeting. I have called this name greeting function, and this start the program function doesn't care about the implementation of greeting function. It just this function doesn't care if you are passing a formal greeting or informal, or what your implementation is doing. It just receives a function and calls that later with the name that you have passed. And also it will print out the name of today at the end of its call. All right, so right now let's go back and run the code. See, I'm right now passing greet1 function to the start of the program, start the program function. Start the program function doesn't care about the implementation of greet1, whether it is formal, informal. It just look at the signature and see, all right, greeting function receives an integer, receives a string. So when we have to call this greeting function, we have to call it with a string, and that's the only thing that we need to know in this starter program, and we don't need to know about the implementation, and we don't care about that. All right, so let's run the code and see what will happen. Error, greet1 was not declared. Okay, I have to uncomment these lines. Yeah, starting the program. Hey, welcome back. Today is Friday, and let me change greet1 to greet2. All right, yeah, this is you see, this is a formal formal greeting, and yeah, that's everything about passing data between functions. And yeah, I also I made a mistake. Hello doesn't have this W, but who cares? Yeah. Okay, right now our code is flawless. Doesn't have any C++ grammatical error. It doesn't have any English grammatical error, and everyone is happy. Hello Reza without any W. I don't know why I put that .w here. All right, anyways, see you, take care, bye.